All right, everyone, it's time for the probability unit test. 9 questions. Here we go. Right, so cereal company is putting 1 of 3 prizes in each box. That means the prizes are evenly distributed, so the probability of winning any given prize is always 1/3. And so Muhammad wonders how many boxes he should expect to buy to get all 3 prizes. He carried out 24 trials of simulations, and his results are shown below. Each dot represents how many boxes it took to get all 3 prizes in that trial. Use his results to estimate the probability that it takes more than 3 boxes to get all 3 prizes. Well, we just have to count up how many trials he did, which we know is 24. We have to count up how many took 3, and that was 1, 2, 3, 4, 5, 6, 7, 8, 9. So if 9 of them took exactly 3, that means the rest are going to take more than 3. And so what's 24 minus 9? It's 15. So 15 out of the 24. All right, you get to pick from 4 pieces of clothing in 3 colors. If you randomly pick the piece of clothing and the color, what's the probability you'll end up with an orange hat? The idea about this is what it's really saying is that you're getting one particular option, specifically an orange hat. And the way you get orange is 1 out of 3. That's how many color options there are. Then there's only one that's orange. And the way you get a hat is 1 out of 4. And we have to multiply these together because essentially we want both happening at the same time. And if you can peel back the wording and say and to get to your answer, it means to multiply those fractions. So we get 1 out of 12. All right. Next we have a question. Is being a senior and not in the choir mutually exclusive? What that means is being a senior and not in the choir, does that never happen at the same time? Well, let's look. There are seniors who are not in the choir, and so that means this is not mutually exclusive. In other words, because there is not 0 here, it is possible to be a senior and be in the choir at the same time. Mutually exclusive means these two things can't happen, which would mean this value would have to be 0. So then the probability is, what is the probability that you're senior or not in the choir? And this gets to one of our famous probability formulas. The probability of senior or in choir is the probability of being a senior, which is 459 out of all 480, plus the probability of not being in the choir, which is 439 out of the 480, minus the probability of both, which is the 436 over the 480. And so when you work that out, that's going to end up being, oh goodness, I'm going to use the calculator today. I'm just going to work out all the numerators. 459 plus 439 minus 436. That number, 462 divided by 480. You might want to reduce that, so maybe actually I will do that. Divide it and then press math fraction afterwards. So it reduces to 77 out of 80. All right. Up next we have an at least 1 without dessert, and the probability of at least 1 is the probability of the complement, or in other words, 1 minus none without dessert. All right, so the question is, what is the probability of 1 without dessert? So we have 7 customers who take an order, and there's an 85% chance that they will order dessert. And so that means the probability of none without the dessert is the same as the probability that everyone ordered dessert. And so the probability of ordering dessert is 85. And we have to multiply 0.85 by itself 7 times for each of those customers. Or in other words, we have to raise it to the 7th power. All right, so 1 minus the probability of everyone getting dessert will guarantee that we found the probability of at least one customer not ordering dessert. Round to the 100th, so 0.68. All right, up next we have a conditional question. The way you read this is the probability that you're in nursing given that you have a bachelor's. And the probability of a given statement is the and divided by the second. So the probability that you're in nursing and have a bachelor's is 0.4, divided by the probability of bachelor's is 0.45. So 0.4 divided by 0.45, and we just need to simplify that. It's improper to write a decimal and a fraction at the same time. So we'll just use the calculator and then press math fraction. Turns out it's 8 out of 9. All right. Chris Paul is shooting 3 throws. Making or missing free throws doesn't change the probability that he will make the next one. And he makes his 3 throws 88% of the time. What is the probability of making all of his next 9 free throws? Well, the probability of making all of them is literally 0.88 for all 9 shots, so either 0.88 times itself 9 times, or 0.88 to the 9th power, which would be this right here. All right, in a class of 10, there are 2 students who forgot their lunch. If the teacher chooses 2 students, what is the probability that both forgot their lunch? And this one is a little bit misleading because to me it should say either with replacement or without replacement. I'm assuming it's without replacement because if you're choosing 2 students at the same time, I don't think that means you're selecting one, placing them back, and then possibly choosing them again. So how do we choose 2 students and they both forgot their lunch? It might be a little bit more technical than you thought. It's not 2 out of 10. We have to think about it like this. So 2 students who have no lunch, 8 students who do have lunch, so we have a total of 10. The odds of getting our first student without their lunch is 2 out of all the 10. But now that student is gone, what is the odds of also selecting the second person who didn't get their lunch? Well, now there's 1 out of the 9 left over. So if you work this out and simplify it, this reduces to 1/5, and 1/5 times 1/9 is 1/45. All right, up next we've got another kind of simulation question here. And so what's the probability that she succeeds at making 10 or more free throws? Well, we just simply have to know how many dots there are in 10 out of 12. And just a math trick, rather than counting up all the dots that are 10, 11, and 12, it might be easier to know how many simulations there were and subtracting how many don't satisfy the condition. So there are 5 that aren't 10 or more out of 25, which means how many are 10 or more? The remaining 20 of the 25, which reduces to 4/5. All right, and just one more. If you flip a coin and roll a 6-sided dice, what's the probability you will flip heads and roll a 1? And the idea is, again, an and probability means you multiply both. So the odds of getting heads is 1 out of 2. The odds of rolling a 1 is 1 out of 6. And so it's just 1 out of 12. Just for the sake of saying it, what if this question had said, what's the probability of flipping a head or rolling a 1? Well, then you would have to do the probability of flipping a head, which is 1/2, plus the probability of rolling a 1, which is 1 out of 6, minus the probability of rolling a head and, flipping a head and rolling a 1. And that would be, again, that 1/2 times 1/6. So notice here, the and is way different than the or calculation. Just bear that in mind, super important concept. All right,